At the Schwarzschild radius, the coordinate time required for an external signal to reach the event horizon diverges to infinity. This asymptotic behavior means that to a distant observer, an infalling probe never actually crosses the boundary, appearing frozen in a permanent state of approach while its light redshifts into invisibility. General relativity distinguishes between proper time, experienced by the traveler, and coordinate time, measured by the stationary observer. While the distant clock records an infinite delay, the infalling clock records a finite short duration to reach the singularity, demonstrating a radical transformation in the functional relationship between two distinct reference frames. The ratio of time intervals is determined by the square root of 1 minus the Schwarzschild radius divided by the radial coordinate. As the radius r approaches the Schwarzschild value, the denominator of the metric term goes to 0, causing the temporal component of the metric tensor to vanish and the spatial component to blow up. Light escaping a deep gravity well loses energy, resulting in a shift toward longer wavelengths. This gravitational redshift is the reciprocal of the time dilation factor. Photons emitted near the horizon are stretched so severely that their frequency approaches 0, effectively removing them from the observable spectrum of the universe. At 1.5 times the Schwarzschild radius lies the photon sphere, where gravity is so intense that light travels in circular orbits. Here, the radial velocity of an escaping photon is 0. Any slight inward deviation leads to capture, while outward deviation allows escape, marking an unstable equilibrium point in the orbital mechanics. Tidal forces arise from the steep gradient of gravitational acceleration over a finite distance. For a stellar mass black hole, the difference in acceleration between your feet and head exceeds the structural integrity of any known material. This differential is a linear approximation of the cubic inverse relationship defined by the Weil tensor. The event horizon is not a physical surface, but a mathematical boundary where the escape velocity equals the speed of light. Inside this radius, all light-like paths are directed toward the central singularity. The light cones of spacetime tilt so severely that the future direction points exclusively toward the center of the mass. Inside the event horizon, the radial coordinate and the temporal coordinate swap roles in the metric signature. Movement toward the singularity becomes as inevitable as the forward flow of time. You cannot stop moving toward the center for the same reason you cannot stop moving into tomorrow. The singularity becomes a point in time. As the horizon is breached, the entire history of the outside universe appears to accelerate in the rearview mirror of the traveler. However, due to the relativistic aberration of light, the view of the outside world shrinks into a small bright circle directly behind, while the darkness of the singularity encompasses the forward field of view. At the center lies the singularity, a region where the curvature of spacetime becomes infinite, and our current laws of physics fail. Mathematically, the density reaches a point of division by 0. This suggests that general relativity is an incomplete theory, requiring quantum gravity to resolve the infinite values predicted by the Schwarzschild geometry.